Today we're going to prove that 0 equals 3. And there's going to be a mistake in the proof, but it's going to be very inconspicuous. And try to comment below on what you think the mistake is. So we're going to go ahead and start with this equation. This is just our starting equation. And we can end up dividing both sides by x. Because if you plug in an x here, 0 here for x and a 0 here for x, you actually end up getting 1 equals 0. So we already know that x cannot equal 0. So we're not dividing by 0, which is a common mistake in many proofs where they trick you in dividing by 0. But in this proof, that's not an option. So if we divide by x on both sides to cancel out the x, which is any integer or any number for that except 0, but it can't be any number, it has to follow the equation, of course, but you get what I mean. Then you actually end up getting x plus 1 over x equals 0 still. Now, I'm going to point out something interesting. If we go ahead and raise to divide by x here and divide it by x here, then we actually can change this equation to x plus 1. If we make it equal to 0 here, x plus 1 equals negative x squared. But you notice that this x plus 1 is the same x plus 1 right here, so you can actually substitute this out to negative x squared plus 1 over x is equal to 0. Now if we continue to solve this, let's bring the x squared to this side. So we get 1 over x equals x squared. If we multiply x by both sides, then we actually get 1 equals x cubed. So then you notice x actually equals 1. So let's plug this into the equation because this is a solution of the equation through substitution, and it's all legal stuff as you can see. So let's plug it in. So we get 1 squared plus 1 plus 1, if we're plugging it into x in this equation, equals 0. And if you solve that out, we get 3 equals 0. So that's the proof of why 0 equals 3. Try to find a solution. It's going to be very hard to find because all of this stuff actually makes sense. So you have to look deeper into why this doesn't make sense. Thank you for watching.